Okay, I got the machine work done finally on this filler. I had to go back and make a couple changes, a couple modifications for strength that I hadn't accounted for in the beginning. And now I have all that done. I added a little bit extra time to the project, but now I'm going to, hopefully everything is squared away, and I'm going to show you the assembly of this. Okay, I just got done machining these legs. There's a video clip of me turning these legs down in the lathe and gluing these inserts in. After I glued the inserts, what I didn't show you is I didn't show you me putting these back in and trimming the ends and trimming these to length. But they're all pretty much exactly 3.5 inches in length. So these have set up enough that I'm going to attach these to the bottom plate, and I'll show you how I do that. There's the bottom plate I showed you before. You've seen the machining of it. You're putting the bolt patterns at it. I'm going to attach these legs. As you can see, I'm putting a 1/4-20 bolt through there. This goes down to the insert on this leg. I'll just go ahead and tighten these up. Once I do this, I'll show you the assembly, the bottom assembly. Now, the reason I put legs on this, as I explained before, there's a fitting that goes through the bottom and then a T fitting underneath here, so I needed clearance. Get the fitting parts. And I'll show you what I mean. Here's a bulkhead fitting. Fits up through there like that. Also known as tank fittings. You use these when you drill on the side of a tank and you need to connect a pipe fitting, or if you're for a drain or a pump or something like that. Agricultural applications use these. I'm not going to tighten up the whole way right now, I'm just showing you. And here's the T-fitting. This is where my valves are going to be connected, either side, and hose barbs. So, yeah, that needs, I need to put pipe tape on that. But anyways, this will show you basically what I got going on. Now, see how that is? I have about a ½ inch clearance under that pipe T, so that'll work really well. And on top of here, remember that manifold I made? I made a manifold, a collection manifold that goes underneath the sand. This thing, the weird looking thing, and then a 3/4 inch pipe fitting. And then this just screws into this bulk fitting down here, like that. There you go. This is the assembly. This, the legs, you got the collection manifold, the O-ring groove, your holes here for the threaded rod, which I haven't put them together yet. I mean permanently. I've checked it for fitment, but other than that. Okay, so this thing pretty much is ready to be put together permanently, and then I still need to finish the top cover. Okay guys, I'm back with a video on how to assemble the sand filter. Remember in the previous videos I showed you how I machined the sub-assemblies, the collector manifold for the top and the bottom. Depends on the operation, if it's filtering or backwashing or rinsing. And this will just show you how everything fits together and how it seals up, and just if you're curious on how something like this might work, I find it interesting, so you might too. Well, first of all, I just set the sub-assembly on place so it won't rock. It's just one more factor I don't have to worry about while I'm assembling it. And here's the O-ring groove, and I'm going to put an O-ring in here. Make sure it's good and clean, make sure the groove is clean, and just set that in the groove. Next comes the body of the filter. I modified this somewhat from my original design because, to make a long story short, it was overkill, and plus I decided instead of using sand, I'm going to use crushed glass media, which has the added benefit of being less prone to bacterial settlement, and also it filters out manganese and iron, because crushed glass has a slight negative charge that will attract metallic ions. That's something I really need in my setup. Okay, that's seated on there. Next, I have these 8 threaded rods. These threaded rods evenly distribute tension across the top and bottom compression plates, or sub-assemblies. And so I already put locking nuts. These lock nuts are here just to keep this threaded rod from turning while you put tension on this hose builder. So I'm going to insert these in the holes. Next comes the top assembly. This holds the distribution manifold. Before I put that on, I need to put another O-ring in place. Just like before, make sure everything's clean. I'll just place this on top. Hopefully it goes right together. There we go, that wasn't bad. Now, as you see, these plates aren't lined up, and they need to be lined up fairly closely before I can attach these bolts, these tension bolts. So what I'll do is I'll just sight down the body of this filter and just kind of look between the parallel the surfaces of the top assembly and the bottom. Make sure they're parallel, or very close to parallel. Then after that's done, I can go ahead and I can connect, or I can put the top nut on these threaded rods. And they just drop in place. This top plate needs to be able to withstand over a ton of pressure at its rating. So there's a lot of stress on this plastic, so I chose 8 rods, not because 4 rods can't stand that kind of pressure, but plastic itself starts to bend under those pressures, so I had to fortify it. We're all in place. Now I'm going to go around, take these lock nuts so they don't move around. And all I do to accomplish that is I just hang on to the threaded rod lightly with a pair of ordinary pliers. Just give it a slight tightening up there. I don't want to preload this plastic too much because I don't want to induce a lot of stress between these 2 nuts. But I'm going to go around them and do the whole thing. Got one of those tight. Now keep the threaded rod from spinning on me when I'm trying to tighten it down here. Okay, I'm going to go ahead now and place all the bottom washers and nuts on the bottom of this assembly. I'm just going to snug that up a little bit. I'll keep the top and bottom plates one solid unit. Now I'm going to do something here for the video for a little bit of clarity to show what I'm doing with those, what I'm doing with the assembly right now, because it's hard to see. I ordinarily wouldn't do this, but it actually will make it a little bit easier. I'm going to flip this upside down. That. And hopefully you can see everything here. This will actually make it go a little bit faster. Putting washers on everything. So that should be alright. That should be good enough for now, and as I bring the pressure up, I'll check for leaks and continue to tighten these down when it's in operation. Okay, let's flip this back over. Clean out the O-ring groove. It's one of those things. Put the last O-ring in. Okay, here's the distribution manifold for the top of the filter. It's the top plate. And this is the last thing to go on other than the hose hookups and whatever needs post-processing that comes out of this filter. And let's see which way this goes. It goes like this, I believe. Center that in there. And it just sits right down there like that. Okay guys, that's it. This is ready to be installed and start processing your dirty water for whatever. If it's a pool, or I use it for my vapor blaster, your water in your house, anything really. Nice thing about this is the glass media will last for, I mean it varies on your usage, but they say anywhere from 5 to 10 years, 7 to 10 years, something like that. And when it gets dirty, you just backwash it, rinse it, and put it back in operation. There's no cartridges, and in theory, this stuff filters down from anywhere from 5 to 7 microns. And that's another reason I chose this over sand, because sand filters down to approximately 20 to 30 microns. And this will work good because my post filters will polish any material out, and this will take the vast majority of particulates out of the water. That's really what I need because I was going through a lot of filters. Hey guys, last night I put the cover on this sand filter and pressure tested it to 10 psi. I use a little pressure for safety reasons, and I leave it on there for about an hour to see if it loses any pressure. Well, that was last night around 6 p.m. and so yeah, so we're like 18 hours later now. I had to look at the clock. So here it is, still holding 10 psi. don't know if you can see that or not. But yeah, so that tells me if there's any leaks at all, this thing would have drained out overnight. So I'm happy to report that. Now I'm going to go ahead and hook this up to my vapor blaster and get the pump in line, the settling tank, all the valves, and see how everything works. Okay, so I have this filter in the testing phase now, and I have the pump running. You can hear it in the background. You see normal operating pressure here with normal restrictions such as pipe elbows and going through all the filter parts, and just resistance to water flow. There's no filter media in place in any of the cartridges either. This is about 10 psi, and that will be considered my reference point of free flow on this filter. Now I've tested this out to 50 psi so far. That's the maximum pressure of my pump, and you'll see here, from the bottom I had a couple of leaks, and these tie rods, I needed to increase the tension on these tie rods so the O-rings would seal. I'll try to show you here when I operate the valve down here to show you this thing is operating to 50 psi without leaking. You'll hear the pump change its tone. It's a 50 psi, and I'm happy to report there are no leaks. I don't want to take it to that psi, but I needed to make sure it could do it without leaking. So it's about 2,500 pounds of pressure on that top plate at that pressure. So everything holds out well, and it's back down to 10. Okay, I just wanted to show you guys that, to let you know it works. I have my crushed glass media. I'm going to put that in next and take a pressure reading, and go ahead and put my string wound cartridges in, my other three my polishing filters, and take a reading there to get a baseline PSI, and let you guys know how this works. Anyway, this is filter glass, and instead of using sand, which can harbor bacteria, this is ground up. It's actually pretty neat looking. You see it there. That's ground up recycled bottles to 20 and 30 mesh. It's pretty big. This has a slight negative charge, glass does, and it's supposed to hold on to metallic ions. So it's going to be interesting to see how well this works. So this is one of the newer things they offer for swimming pools. So I'm going to start putting it in there. I probably won't do the whole thing on camera here, but just go ahead and dump it in. You can see in there. Okay, I finished putting the filter glass inside the housing here. It's kind of hard to see depth with one lens here, but it's up. It went about 2/3 of the way up through the housing, and that's what I want. So you see there's some particulates here along the side. It kind of floated on the water. This is the water line when it came up. I just drained it out to show you, so you'd see the filter bed down there, but some of this media floated, so I don't know what kind of material that is. So, but I mean, it doesn't matter. It gets washed out, filtered anyways. So yeah, I'm gonna put the top back on and start circulating some water through this and see how well it takes the iron out. I'm looking forward to seeing how well this thing works. I've heard a lot of good things about them. And I'm just waiting for the pump to kick in, and the filter media is in place, 50 pounds of it. There, the gauge is going up, and you'll see, I don't know if you can see this different than last time, but I'm getting, okay, where's it at? There we go. I'm getting 1 psi of resistance through 50 pounds of crushed glass. And remember before, with nothing in that filter housing, I was running at 10 psi, so it caused a 1 psi change. That's really good for a filter. I'm real happy about that. It gives me a lot of leeway for filtration before I'm at my maximum rated pressure for this filter. Yeah, that's going to work out great. 3 filters installed, a 10, a 5, and a 1 micron. And those just take out anything that this filter misses. So this will take out the bulk of pollutants out of my water.